Alright, so this is problem 10 out of the textbook. Before we start, please subscribe to the channel. It's a nice way to help the channel out and help me out. So this is problem 10 out of Kenneth Crane's Modern Physics book. Two spaceships approach Earth from opposite directions. According to an observer on Earth, ship A is moving at a speed 0.753 c and ship B moves at a speed 0.851 c. What is the velocity of ship A as observed from ship B? Of ship B as observed from ship A. So it's the basically same question, I guess you could say, from different perspectives. So we have ship A on the right moving towards Earth, and ship B in orange on the right moving towards Earth. And they're moving in different directions, so we want to keep that in mind. Now, there's an equation, kind of our main equation we're going to be using here for velocity addition. And if you have no clue what any of this is, I'm pretty sure I made a video on the entire topic on my channel a long time ago that you can watch. But if you guys want me to do that, then, and I didn't do it, then I can do that. I might do that as well in the future here, just talk about concepts besides just grinding through problems. It's supposed to be a prime. But at least for me, it was helpful to see people work through problems. I learned the concepts better that way. So this is our velocity addition equation for relativistic speeds. And we'll start for ship A. So for ship A, what does ship A see? Well, ship A is going to see a ship B moving towards it, moving towards the left. So just conceptually, we know that it has to have a negative velocity if we're letting right be positive, then it's going to appear to have a negative velocity. So conceptually, that makes sense. I like to think of this as if you had two cars. If you're ship A and ship B, obviously no one's been in a rocket ship unless you're like an astronaut, but I don't really know why you're on this channel if that's the case. But we've all driven in a car, I've been in a car, and if you had two cars going head on, it would look like the cars are moving really, really fast towards you. In reality, both are going at half of that speed that it appears. So if you're going 60 miles an hour and they're going 60 miles an hour and you guys are driving head on, which I don't recommend, it would look like the car's going 120 miles an hour. Now, obviously, with relativity, it gets a bit different because we can't exceed the speed of light. So that's where this equation comes from. So let's see. The way I think about it, this, U, is your speed. Or I should say speed of your reference frame. So the speed of ship A's reference frame is given in the question. That's just this. This is going to be other ship reference frame from the perspective of, in this case, Earth, which is, they're both given, so it's no issue. And then all we have to do is plug it in. So in this case, what are we going to have? Well, we have V prime and we have U. So V prime is the speed of the other ship. Well, it looks like the other ship is moving to the left. So I'll do negative 0.851. I'm going to factor out the C in the end. I'll actually just put it right there. And then for ship A, your speed, or your reference frame speed, it looks as if everything else around you is moving to the left at 0.753. So you could think of that from your speed, your reference frame speed. Even though the ship is moving to the right, it looks like everything else is moving to the left. So if you put yourself in here, it's kind of a weird idea. But not really if you think of your car. If you're in that ship, sure, you could say that you're moving to the right, or you could say everything else is moving to the left, which is how we're interpreting it now. Right? Just like if you had two cars colliding with one another, you're not saying, well, I'm moving to the right. It would look as if everything's moving to the left. Right? So we could also factor out this negative, which is what I'm going to do. So I'll move this over here. I'll put a negative here, a c here. 1 plus u times v prime. Now that's going to be a negative times a negative, so I'm not going to worry about it. They're just going to become positive. And c times c is c squared, so you would have got a c squared here, but that's going to cancel with this c. And when I put that in, I get negative 0.978c. So that's how fast ship B looks to be going to ship A. And that makes sense. It should be going faster than it's actually going, but it shouldn't be going faster than the speed of light c. Neither of those is happening. It is going faster, but it's not exceeding the speed of light. The negative sign also makes sense for the same reason that we discussed earlier. It looks like the ship is moving to the left really, really fast. That's where the negative comes in. For ship B, the only real difference is the direction. So from ship's B point of view, it looks like ship A is moving to the right at the speed it's going. So the only difference is, again, from ship B's point of view, this guy's moving to the right, and, you know, you're in here. It's a weird looking guy. It looks like the Earth and everything else is moving to the right, so we're just going to straight up add these guys. Factor out the C. I like to do that because I like everything in terms of C. And then there's no negative times negative. They're just both positive numbers now. And you can see quite obviously here, you're going to get the exact same answer, only a different sign. And that makes perfect sense. It makes sense that you're going to get the same answer. The only difference is the direction that they're moving. You should be getting the same answer, right? So this is good. Now, obviously, this problem, depending on, you could have ship A being on the right and ship B on the left. That would just change. That would just flip the answers. But it shouldn't matter. The book doesn't specify. Yeah, the book doesn't specify if ship A is on the left or ship B is on the. It doesn't really matter. So we're going to use our velocity addition equation. We're going to apply them correctly to get our two answers. So hopefully that helps out. If it did, please give a like